Okay, I wanted to give you another illustration on the empirical rule. This is for chapter 3. I'm kind of adding something. Your book does mention it, but they don't go into a great detail in terms of how it's actually used. And I know I put one of the homework problems where they're asking you to do some sort of empirical rule application. So I'm using this PowerPoint mix just to kind of give you a quick illustration to help you succeed in learning how to use the bell-shaped curve or the empirical rule. So notice I'm going to show you the distribution shape. I'm going to talk about a z-score idea, which they also do that later on in chapter 6, I believe. I'm sorry, chapter 7. And then the empirical rule, I'm going to show you what that means. And then I'm going to talk about this thing called an outlier. And then I'm also going to illustrate a couple ideas on how to apply the actual rule. So before I actually show it to you, here's a formula in terms of what they call a z-value, which is often called the standardized value. And it basically tells you where you're located, where the item or the data or the observation is located in terms of how many standard deviations is it located compared to where the mean is. Okay, and just for example, xi would represent the observation, x bar, which is your sample mean, but you could also substitute mu in there depending on what's given in the problem, and then s would be your standard deviation. So let me erase this, let me rewrite it. So you could also look at it, I'm going to write it down here, look at it like this. You could also say the z-value equals, sometimes you might see it like this, x minus mu divided by sigma, which is basically the same idea. You're trying to calculate how many standard deviations you are located compared to the mean. And you're going to find that in this particular slide, it talks about, the different things that the z-value can do. Again, it's your observation set, your relative location compared to the mean. You could get negative z-values, you could get positive z-values, you could get a z-value that's equal to 0. And all that basically means is if you get a negative, z-value, like for example, it says in this little bullet, so you could get a negative z-value, it basically just means that you're less than the mean. If you get a positive z-value, it just means that you are more than the mean. And obviously, if you get a z-value that's equal to 0, it means you are at the mean. Okay, so real quick, if I were to draw, like for example, a bell-shaped curve, and this is kind of like how we're looking at it. So again, you're going to be putting the mean, I'll just use mu as my example, right in the middle. And if you were to calculate a z-value for the middle value, you would say that the middle value has a z-value that's equal to 0. And so then anything to the right of this would be a positive z-score. Anything to the left of this would be what we call a negative z-value. So as you can see, here are the rules, and we're going to go over how to calculate these later on, in terms of the chapter on continuous probabilities. But just for now, take it like this, and you can just kind of cut off these decimals. You can say that for data having a bell-shaped distribution, that basically approximately 68% of all data would be plus or minus 1 standard deviation compared to the mean. 95% approximately would have values that's plus or minus 2 compared to the mean. And notice this one, 99%, almost 100% of all values would be within what they say plus or minus 3 standard deviations of the mean. For now, do not worry about where they're getting these numbers, just kind of use them as empirical research. This is what they've observed, and this is pretty much given as a fact, and so we're just going to use it for now, and later on we'll show you how you calculate it. But in the next slide, it's a good visual to show you pretty much how the bell-shaped curve looks with each of these standard deviations under the curve. So as you can see, notice that they put, here's the means in the middle, and then you go plus 1, which is right there, and minus 1, which is right there. Notice they're saying that's about 68%. And then notice when you go any farther, you've got a plus 2 right here, a negative 2 right there, and notice they're trying to show you that that's about 95%. And then notice once you get to the very end of each of these tips under the curve, that's a plus 3 or a minus 3. They're saying that's basically almost 100%. So what does that basically mean is that when you're sampling data, and we're going to get to this later on this semester in terms of taking samples and calculating their relative location compared to the mean, it's that universally the truth is that pretty much all data should be within plus or minus 3 of the standard deviation. But notice this does not say 100%. So therefore, you could get data values that could be way up here, and you could also get data values that could be way down there. So it's more than 3 or less than a negative 3. And anytime you get that, we're going to call those things outliers. Okay, and that may come up later on. So an outlier could be a data that's going to be way, way out here under the curve. It's going to be less than a negative 3, or it's going to be more than a positive 3. And typically those things are referred to as non-normal distributions or anomalies. Again, it's not within the normal curve. Okay. Okay, and so I believe the one in your homework is asking you to do a couple things with the bell-shaped curve, and I'm just going to draw you the curve right here. And so let's say, for example, we are in the middle, and we're going to say here's mu. And let's say we wanted to go out plus 2 z-values or a minus 2 z-values there. We're going to tell you that that's essentially going to be approximately 95% of your data. And so one of the things you can do with these bell-shaped curves is you can take them and cut them in 2 pieces. Just divide it in half. Now, when you do that, from this data point to this data point, if that's 95%, and I were to cut this curve in 2 pieces, and again, these are approximates, we would then say that from the middle data point, which is 0, down to a negative 2, would be about 47.5%. And then the same thing, if we went from 0 to a positive 2, that's also about 47.5%. Again, these are approximates, but just using the symmetry of these bell-shaped curves. So in some of the homework, and I think I put this on the illustration, is when you're trying to find anywhere, for example, between a negative 2 and positive 2, we know that the answer is approximately 95%. But in any case, if we were just trying to go from the middle data point, which I believe that the homework says between x and a positive 2, that's from basically saying 0 up to a positive 2, you essentially take half of the 95, and the answer would be 47.5. And notice that'll be the same for each side. Okay. Now, one last thing about this, and this always comes up, is because you can take, I'll draw this over here. So if I do this again, pardon my illustrating, I'm not the greatest artist, but again, if you divide this curve in 2 pieces, just in general, each side is said to be 50-50, right? So if I'm looking at this one, if I go 0 to 2 is approximately 47.5. Well, if I need to get to 50 to fill in the hole to get to 100%, I would know that that little area would have to be about 2.5%, just like this little area would also have to be 2.5%, okay? So sometimes you might be asked to find areas later on under the curve if it's going to be more than 2 or less than a negative 2, and use this maybe to help guide you, but that's all you're trying to do is, if I cut it in half, the middle value is 0, 0 to 2 or 0 to negative 2 is half of that 95, and if you're ever trying to find a value that's more than 2, it's just going to be 50%, write this up, or 50% minus the 47.5%, that would get you the 2.5, which would be that part of the curve. And let me just kind of give you another illustration, not just using the plus or minus 2. Let's say we were doing, we're looking under the curve for the plus or minus 1 standard deviation. So again, let's say I draw my curve. Here's my line. And again, I put the mean in the middle. And if you go -1, +1, and draw my lines here, the rule basically says that's about approximately 68% of all data. So what I would do again is I'm going to split this curve in 2 pieces. I know the middle value is said to be 0z because that is the mean. And if I wanted to know from 0 up to 1 or from 0 down to a -1, all you do is you take that 68% and divide by 2, and you would say that that's 34 and that is 34. Okay? And so very similar to the other example, because we are still thinking just in terms of the curve. Anytime you look at the curve in 2 pieces, you know, the middle, the mean, the median, the mode is the middle value. Each side is said to be 50-50. So if I know, for example, from 0 to 1 is 34, if I were going to try to find that area, it's just going to be 50 minus 34, which would be 16. So that would be approximately 16%. and it'd be the same value over here because again each side is said to be the same once you split this thing in two. So again, I'm just trying to show you just a couple applications on how you can cut the curve in a couple pieces and dissect it and use those standardized plus or minus 1, plus or minus 2, or plus or minus 3 areas to figure out different areas under the curve depending on what a problem might give you. Now, they don't go that much into detail into chapter 3, but I wanted to kind of give you this just as an extension. You'll use this later on when we get into, I believe it's chapter 7, when we get to the continuous variable. They do talk more in detail about how to do this, but I just want to try to help you get started. Eventually, it's going to get a little more detailed than this, but this is how you apply the bell-shaped curve.